Hi, this is Aaron McLaughlin with the Happy Lab at Georgia State, and I'm going to be walking you through how to do a moderation. Before we walk through it with SPSS, let's ask first just what is a moderation analysis? Using this diagram to the right, a moderation analysis is looking at how one variable is influencing the relationship between a predictor variable and the outcome variable. So the questions that are being answered by a moderation analysis are when or under what circumstances or conditions is the relationship between a predictor variable and an outcome variable happening. So some people look at a moderator variable through the metaphor of a volume knob turning up or down the relationship between x and y. So what do you need to have in order to do a moderation analysis? Well, first, you need to have SPSS statistics software. Then you need to get process. To get that, go to processmacro.org and go to download and click to download and set it up with SPSS. In the files that come with the process download will be a template with many models. There's over 70 models of different diagrams of conceptual relationships involving multiple variables, so it's important to know how to pick the right one. And first, that just starts with what is the theory you're working with and the question you're trying to answer in your statistical analysis. And then once you have a diagram that you draw, you look for that diagram. So the simple moderation model in which one variable is moderating the relationship between two other ones looks like this. And statistically, it would look like this. You have your x variable, your moderator variable, and then the interaction of your x and moderator variable predicting y. So now that we've gone through the template, let's look. You also need to have multiple variables in the data. As you see, in a simple moderation model, you have 3. So if you have 2 variables, you are not using a moderation analysis to answer your question of the relationship. So now let's, in addition to that, you need to know that your variables are usually stable and trait-like variables. They're not variables that are so easily moved or temperamental. They can also be dichotomous variables, like yes or no, 1 or 2, or continuous variables, like a continuous string of numbers to measure the degree of the variable. So for the sake of this video, here's our research question. Is a moral foundation of fairness influencing when variance in scores on a self-report measure of intellectual humility predict variance in scores on a measure of forgiveness? We're going to take out benevolent motivations. Of forgiveness. So in layman's term, is a moral of fairness or justice influencing when a person's intellectual humility predicts their rating of forgiveness toward an offender? And we are using a sample consisting of students in seminaries and studying religious degrees collected from Joshua Hook's team at University of North Texas. So let's get into the nuts and bolts of just how to run this analysis. So open up SPSS, click Analyze, then go to Regression. Then you're going to click Process. And you need to move your variables over it. In this case, we've already done it, but from your data file variables, you would click 1 and then click the arrow in order to move it. Then you need to pick your model number. And so in our template, our model is model 1. So we're going to pick model 1. Then in your options, you need to make sure that you have mean center for products picked, your confidence intervals, and to generate data for plotting. So not only do we see numbers that describe it, but we can see a graph that will describe it. Click continue, then go to conditioning, and make sure that Johnson-Niemann model is picked. And I'll explain what that is when we look at the output. Once you've done that, click OK. So how do you interpret this output? There's a lot to the output, and so we're going to go step by step here. First of all, we've got a summary. So here you have your summary of your model with your different variables and the sample size, 240. Now the model summary has an R-squared, or saying that almost 6% of the variance in your outcome variable forgiveness is being predicted by our model, including humility and fairness. Here's our constant, or your y-intercept, of 3.8531. And then you look at fairness. Fairness by itself has a p-value of 0.20, so that is not significant. Intellectual humility as a predictor of forgiveness in and of itself in this model has a p-value of 0.06, so that's not significant. But then when you look at the interaction of humility, the self-report of intellectual humility with the moral foundation of fairness, we do have a significant p-value that's less than 0.05. And it's negative, meaning that the interaction of humility and fairness has an inverse relationship with forgiveness. So if you have a higher score of humility then a higher score of fairness would lead to a lower score of forgiveness. Here we have the R-squared increase due to interaction, and this is telling us that the interaction of humility and fairness gives us an additional 2.5% prediction of the variance in forgiveness with this sample. And again, the p-value shows it's significant. Now, also, one more thing to look at with these coefficients is these are the beta weights. So if you were to imagine like a regression equation line, like y equals mx plus b, these would be your coefficients. So you would have y forgiveness equals 0.10 m plus 0.21 x IHS minus 0.364 mx, fairness and interaction. So let's look at the Johnson-Niemann significance regions, and this is telling us when you have p levels that are significant, so all the way up to minus 0.0342, that scores of fairness that are about at the mean or lower are significant in this interaction effect. And so that's telling us for what scores of fairness is the interaction happening in a significant way. And in this case, it scores basically at the mean or below the mean. So here's data to help us kind of put all of that together. And so what I want you to do is you would go down here and you would copy, starting at data list, and go all the way down to here. And then you're going to open a syntax file. And you're going to paste it. And then click play. And now it's going to give us a scatter plot. That's the wrong scatter plot. Let's do that again. Let's cut that out. Something didn't work. And let's go to our syntax file. Highlight it. Click play. And see what the graph does this time. This time we have 3 plots for each line. But those plots are kind of hard to know what's happening. So double click it to get into your chart editor. And then you're going to click on this table, click on variables, change element type from marker to fit line. So you want to make sure it says fit line. If you're wondering, if you're on this, you just simply go to variables, change marker to fit line, and apply. And now it's given us 3 lines. So when we look at this graph in our output, we can see that for scores at the mean, you have this general direct relationship in that the higher scores of intellectual humility are predicting higher scores of forgiveness. But when you add a moderator in for scores that are lower in fairness, the higher a person's humility is, the higher their forgiveness is. But you see this negative line for when the scores are above, that it actually, for higher scores of fairness, then the higher someone's humility is, the lower the forgiveness is. So now that we've plotted the graph to look at the moderation, there's one last step, and that is, what does this look like on the conceptual model? So let's look at this template and our output. And for our interaction effect, the coefficient was minus 0.364. And so that line right there is minus 0.364. I hope this was helpful for you in understanding what a moderation is doing and how to do it. Thank you.